Hey everybody, this is Justin from TestDouble, and I want to talk today about mock objects, and particularly how I use them in the particular brand of unit testing that I practice, which I've lately started calling discovery tests, because since classical TDD practitioners, as well as isolation testers who practice Goose, which Goose, by the way, GOOS, stands for Growing Object-Oriented Software Guided by Tests, which is the book that kind of founded the activity in a lot of ways. Um, Using the term unit test conflates things. People who practice classical TDD use mocks, but they tend to use them tactically here and there to make their testing flow more convenient. And this leads to, I think, an ad hoc understanding of mock objects, that they're this convenience that is to be minimized. Whereas people on the Goose and Discovery side actually have a very, very narrow use of mock objects. And that is to discover new dependencies as they're starting from the outside of an application and trying to figure out what's a healthy, usable private object API internally to the application. And I'm actually very, very rigorous about how I use mock objects. I would go so far as to say that I love mock objects. I really, really think that they help provide clarity to my work. And in particular, they help address the anxiety of, oh my god, I just got this massive story that I need to implement. And how can I possibly break this down into smaller, more manageable, bite-sized things? In particular, I don't love so the nuanced and scientific part of me doesn't love mock objects per se, because they're a special subtype of the broader category of test doubles. So if you've ever been confused about our company's name, a test double is like a stunt double. It's something that stands in place of a real thing for the purpose of being able to write a test. And obviously, if your whole testing practice is about discovering things that don't exist yet, you're going to need a lot of test doubles. Not just initially when you're first creating everything, but even keeping those in place so that each test could only test the symmetrical partner of the thing that it's specifying, and isolating itself from all of its neighbors. Let's say that you have a hypothetical feature. We're going to just use this as an example today. And first draw off on kind of like a fake whiteboarding activity, and then switch over to code and write an example test. So this hypothetical feature that you get is a story card, and it wants you to generate a random arithmetic problem via a web service. So for example, that might be 5 plus 3, and you need to give it some JSON to specify that structure. You also need to store it on the server, maybe even just in memory, so that some subsequent request could find it. So you probably need to give it some kind of ID that you can keep track of. And you need to accept attempted solutions to some other route, some like post or put route or something, and respond with a HTTP status code that indicates that the user successfully answered the arithmetic question or did not. And, maybe this is used in some educational game or something. So the example structure that we might come to after some doodling would be to, provide a response that has an ID indicating the saved bit, the actual generation of the pieces, the operator, as well as the left and right operands of the equation, and then also a human-readable description in case anyone pokes under the covers and wants to either maybe a UI wants to print it and we just provide that. Obviously, it's a little bit trivial. Or somebody wants to just look at the API and response and know at a glance what it means. So if if we were to sketch out what the first object is that would respond to this route, you could imagine there's some function that's responsible for getting a random problem. And when you think of all of the tasks that are involved, we think back to those acceptance criteria. And it's pretty straightforward that there's 3 primary responsibilities here. So I could just start writing a test and implementing everything in that test, and then just sort of be bound by the professional law of good software developers to refactor later and pull out the subordinate bits and structure those well. Or I could, if I wasn't practicing TDD, just start writing code and hope that I land in small units that are maintainable. But instead, with discovery testing, it's sort of like a structured activity where we write an executable example to figure out, boy, I wish I had this and this and this. And if I only had those 3 things, man, everything would be great. So in the first example here, I might say that it would be really nice to have a thing that just generates the random problem separate from the concerns of saving it or writing that description. Then it would be nice to have a separate thing that just saved the problem off, and then that way, that could grow into its own complex mess of maybe persisting to a file store or a database later on. But it also needs to generate the IDs for me and all that. And then something else that describes the problem, like a presenter that takes whatever my internal representation of the problem is and, unmarshals that marshals that into some kind of JSON object or supplies that description parameter to the value as it's passed back out into the HTTP response. So I'm going to transition now to code. I have a simple little empty node application here that we can use. So if I type in tree, of course, because there's node modules installed, it looks like it's this gigantic, massive thing, so that's not particularly helpful. Instead, I'll open up Atom and we'll look at it. So it's got an empty lib and spec with just a simple spec helper in there. We'll see what that does in a second. A little grunt file and a packaged JSON. This is just something I threw together today. Grunt Jasmine Bundle is a special grunt task that incorporates Jasmine mini node as well as all of TestDouble's Jasmine helpers like Jasmine Given, Jasmine Stealth, Jasmine Jasmine Only, Jasmine Before All, like a whole myriad of them, hence the term bundle. And I guess we could say that we do have a script for test. We can say grunt spec default, and it's gonna what the default task does is and the default task and target do is they look in spec here and then we'll run any specs that they find. So when we have 0 specs, it should be pretty straightforward. We could run that now that we have the test script set up. We could either run that with npm test, or we could just say grunt spec, and because I made it the default, we could also just say grunt. Sweet. So we have no tests. So let's write that first test. Now, remember the purpose of this first test is to have like an executable way to just prove out the relationship between these 3 things that I wish I had, not to actually implement anything. So generate random problem, maybe? No, and in fact, let's say gets random problem because it's about the HTTP method. So gets random problem dot spec dot coffee. So let's start a basic description here. Gets random problem, and I guess it would have a method. Probably not bother making an instance thing here. Just use an object with a function. Okay, so it has a method get, and because I'm not going to actually be generating a real value here, I don't really care or know what the result is, just as long as all of my interactions between these things that I depend on, as long as those interactions happen, that's what I'm really testing for. So my action here would be to say, let's see, so suppose I have this guy, and I'm going to say require subject lib gets random problem. When I call get, so subject equals require subject. When I call subject dot get, now at this point I'm thinking like there's probably no parameter this thing needs if it's giving a random thing back. Then I guess, and I'll assign that to some kind of result. Then result equals a random saved described problem, right? Because it needs to have all those things. So let's pause here and start running this test to put in enough infrastructure to change the message until we get to our logical failure, which is going to be that like undefined does not return or does not equal random saved described problem. Also, let's use the equality operator here so that it actually performs the test. So let's grunt. All right, should blow up lots of things because it can't find that module, and also get isn't defined on it. So we can create that quickly enough. Add a file. Gets random problem dot coffee, and we can say module dot exports equals get. No, we need that much. Okay, that didn't work. And now it says, then clause, this result, random saved problem failed, returning false. And Jasmine Given does evals on either side of comparators to try to tell you what the actual values were underneath. So it says undefined, of course, does not equal random save described problem. So now we have an idea of the basic structure of actual things that we need. I'm going to pass to require subject. This is a little bit tricky. This uses a tool called sandboxed module, which is an NPM module that lets you basically donkey punch the basic require functionality of Node, and it's probably best to just see it by example. So hypothetically, if I were to, from my subject, require this thing with this string, like the first bit that I keep accidentally typing, would be generates, let's call it generates problem. If I were to require that, I'm going to get this object back, generates problem. And I can define it inline because it's a CoffeeScript expression. I could say Jasmine, actually I was set up this way, generate jasmine.create spy. And because the top level method takes no arguments and it doesn't make sense for this to take any arguments either, it should just always return something. So I'll just say and return random problem. Okay, so now if I were to require generates problem and call a generate method on it, it would return a string back called random problem. And I'm going to use this like a baton and pass it to the next thing to force me to actually implement this interaction correctly. So the next thing I might create is called, saves problem is the most boring name I can think of. So saves problem equals save, jasmine.create spy. Now I'm going to say conditionally, this is a Jasmine stealth feature. When it receives random problem, then I want to return random saved problem. And of course, conditional stubbing is really important because I want to actually force it, right? It wouldn't make sense to just always return it because then it wouldn't actually test the interaction that I care about. And then finally, the third bit is this thing that describes the problem. So describes problem equals describe, and again. Now, if this was a real project, I'd probably write some helper facility to facilitate this being a lot easier, because I'm going to be in this pattern over and over and over again. Let's see. And because the require statements could be inferred here, I actually might have the test output while it's failing print out for me what the require statements it's looking for are, just so I can grab them and paste them easily. Because one of the nice things about this approach is that when you're making what I call a collaborator object, one of these guys, the test looks so darn consistent that you can actually get a lot of benefit from writing tools that either automatically inject your fake things that don't exist, or otherwise just consistently generate what you need for you. Something I actually miss from the Java world. Alright, so random saved problem was the thing this guy will receive, and he's going to return now the thing that we actually want because he's our final destination of collaborators. Alright, so random saved described problem. Now, when I run the test, I should see the exact same error message if I set up my mocks correctly. And I do not. Object has no method then. So I seem to have screwed this up. Oh, yeah, then return, of course. Excellent. So, still getting the undefined failure. So I'm going to go split over here. I'm going to steal just these guys. Oops. Just these strings so that I can require them each. So I'm going to call it generates problem. I like really, really boring, consistent naming. Like I wouldn't call this generates problem mock or generate. It's not a mock, it's a spy object. In my test, because I want everything to be eminently greppable and easy to find and consistent and not redundant unless necessary. All right. There we go. So I'm now requiring all the things I meant to. So generates problem dot generate should be able to be passed into saves problem dot save, and whatever saves returns could be passed into describes. And this might look a little silly, but you can actually see that when you set up interactions this way in this thoughtful manner, it really favors a functional kind of style of values that pass through the system and then get returned, and could just as well, instead of passing a thing and mutating the thing, could just as well be wrapping new things and taking advantage of immutable data structures and all of the obvious benefits that those can convey. So let's see if we got passing. I hope we did. Good. Now we got a passing test. And now I am done with Git's random problem. I expect to not have to worry about that code again, and I have 3 smaller problems to deal with. So going back to our presentation, I have these 3 little things, and if we were to continue this exercise, we'd probably dive first recursively into generates random problem, the generates problem object. And I imagine that would have 2 primary responsibilities, because math random in JavaScript just returns a decimal number 0 to 1. It would be really convenient, though, to have something that would provide a random character from a set of characters, like plus, minus, star, and slash. And it would also behoove us to have something that gives us a random integer, because we want these problems to be like maybe 0 to 100 on either side. Simple little functions, but those would be leaf nodes and not use mocks. So the benefit of this approach is that for the high anxiety among us like me, we can just code by wishful thinking at each level, and once we've got that top level test passing, our focus can narrow to one of the logical subtrees of behavior in the thing that we're building. So the focus benefit is tremendous. The other benefit is that because all this mock setup stuff is a little bit hinky these tests don't provide us with any value other than the upfront specification of the things that we wish we had, with like a handful of bits of feedback of when those interactions are weird, or when the data types flowing from piece to piece to piece don't really make sense. I mean, that there's some definite value to those tests, but the real meaty tests that we all love to write are, here's a normal function, it takes 2 parameters, it adds those 2 things up, and then returns you a thing. Because those tests actually do provide a real regression value, and they tend to be really straightforward and obvious, and any workflow that helps me write more obvious, simple, small things is a better workflow. So in this case, our 2 leaf nodes, which I sometimes call like logical units or pure functions, are right here, and I would just write normal tests against them to test the parameters. Now, obviously, testing randomness leads to some determinism problems, but I could just put the ranges there and then trust that every time it runs, it'll fall within a given range, and probably not lose too much sleep at night. The other thing about leaf nodes that's important to keep in mind is that there's no mocks. We wouldn't use a mock in this instance. We would want the regression safety that is possible from testing a pure function like a function. And it wouldn't make sense to introduce mocks into something that we're also trying to get regression safety from, because then the story isn't clear. I think that most of the mocks that you've probably seen in a test suite in a real application is a test that is trying to get regression safety back, like tell us that the thing is working. And yet these mocks are doing nothing but diminishing our confidence that we're testing a real thing under realistic conditions. And so I like to have a very clear divide between this is a collaborator test and this is a leaf node where I'm really trying to get verification that it's working from that test going forward into the future. Up here, these 2 other things that we've talked about so far are what I call collaborator objects. And collaborators might be a query, like this one, it's getting a random thing and returning it. Or they might be a command, something that has a side effect, like, takes a post and then saves a thing. And those 2 have their own different structure and flow, but the important thing to know at this point is that when you're creating a collaborator with a discovery test approach, you are only using mocks. You're only using fake things to discover littler things, and you're not giving that thing any responsibility to have any non-trivial logic. I mean, it might make sense to loop over some stuff, or have like a single branch of I pass to this thing in this case and I pass to this thing in this other case. So I'm not saying that it's like always going to be as brain dead as just delegates to 2 or 3 things, but it pushes you in that direction because those tests are indeed easier to write. If we start to let logic creep from the top down, we have the same problem as if we had a logical unit in the bottom with a whole bunch of mocks in it. We start to lose our confidence that that test is actually providing any regression safety. But moreover, if you think in terms of design, separating those two responsibilities, a thing that's good at calling other things, and a thing that actually, has some functional worth of computing something or transforming some data structure into some other data structure, separating those is tremendously beneficial to our ability to jump in and understand it, because it's going to be smaller, and it's going to allow for abstractions that benefit it. Like, for example, a collaborator's types of like higher order abstractions are going to look like something like, oh, we're doing this a whole bunch of places, calling a whole bunch of things in a certain way. This would really make sense to, let's see, map or reduce or build some sort of mix-in that handles this for us, or provides some sort of like other structure or pattern, like servicey pattern. Whereas the lower level stuff tends to lend itself well to being very simple and small, and maybe getting wrapped up in higher order functions, like using just traditional composition in functional programming. Now, I've been talking about functional a lot, using the term functions and promoting benefits of functional programming, but this is something that you can get from, like, using a classical language too. It's just that your classes end up looking sort of like window dressing syntax around what are really just like dead simple little functions of behavior that become deeply nestled down and bubble up into higher order constructs. So two common concerns with this approach that people raise right away, and it's totally fair, is that that's too many things. You'll end up with a whole bunch of different types, and they're all over the place, and that's a lot of cognitive overhead to somebody who's first reaching the team. But the benefit of this tree-based way of visualizing your code and organizing it is that the number of types that a user or a developer, is exposed to is at the very top level going to be roughly equivalent to the number of things the application does, like the outer routes that a user sees. And to the extent they need to dive in, they'll probably just learn that as they kind of dive in through that tree structure and go deeper and deeper, and only care about the thing that they're actually concerned about, sort of like they're steering themselves through the code base. The other benefit of having a lot of these types be one-off, like rediscovered every time and be really small, is that they tend to not be reused. And I know code reuse is like lauded as this really awesome and fantastic thing, but code reuse has a cost, right? If you find some bit of code that is usable in two places, you do get the immediate benefit of being able to not have to write it again, but you have the long-term cost of any time that thing has to change, it needs to consider the needs of both of the people that call it. And if you have a thing that's used in 7 places and you have more integrated tests, then you run the risk of breaking all 6 other tests when you change it for the need of just the one. Even if you're isolation testing like this and you've successfully reduced the redundant code execution of that one little thing, then you still have to concern any changes to the public interface of that reused item. So I think code reuse tends to be overrated and tends to be more expensive in the long run than we give it credit for. The other thing we give too much credit for is changing code and building code to be maintainable over the long term. My goal has always been to make such tiny methods and such tiny classes and such tiny web services that they're theoretically disposable. If I get hit by a bus later, somebody should be able to find this particular service and rewrite it without, a tremendous amount of forensic activity. Such goes the case with this as well with discovery testing. Oh, and look, the same slide just showed up twice with 2 different formatting. Oops. So in the discovery testing example, pretend that like a new requirement were to come along the way, and pretend that our hypothetical feature looks something like this. It's like this big tree, and at the very outer level it does a hard thing, and it does, underneath that some kind of query and some kind of transform, and ultimately has some side effect somewhere else. But the thing that we actually want to build maybe is has to do with how we fetch stuff or how we paginate stuff. So that subtree right there in the middle. So the first step of any feature requirement after you've built the initial thing is to identify, what's the smallest subtree in your behavior graph that's going to be affected by the change. And in that case, maybe it's right here. And then second, if that change is not trivial, meaning it's like a bigger change than just, like, oh, I need to call this extra new thing now, or I need to call this in a different way, or do these operations in a different order, literally just delete the whole subtree and then drive out a new solution. So, we'll fetch stuff better and we'll paginate better in this new way. The goal here, or the primary benefit, is that this pays down technical debt because it trusts that future us will know more than current day us. We're always learning more over the life cycle of any product, a better way. Like, man, I wish we could have done X feature with Y knowledge that we have since learned. And I think the true definition, or the original definition of technical debt, was really describing that delta. It's like the understanding of the product in the business domain on day one of a project is going to be far less than on day 1000. And that gap in our understanding of how we would have built the system with our perfect understanding, that is technical debt. So if you build a workflow that reduces the amount of change to code, you'll be better off. Because ultimately, when you change big code, that's hard, we all agree. And when you have long methods and changing that, that's hard, we all agree. And when you have old code that you haven't visited in a long time, trying to change that is hard. But really, the fundamental crux is that changing all code is hard. And it would be better for us to develop a workflow that actually encourages disposing code rather than changing existing code. That's probably a somewhat provocative statement, but I found that it's actually hugely liberating and lets you come up with all of these new practices that are both helpful from an initial productivity perspective, but kind of put off a lot of the downstream worries about how maintainable a piece of software is going to be. So that's all I got today. I threw a lot of concepts kind of at the wall. I hope that some of it's useful, and I hope that it can start a discussion about yet another way to think about mock objects and test doubles. Thank you very much.